am Vishesh Wadhwa. My roll number is 102006129 and I am part of the group Drishti AI. Our group number is 56.
My name is Sidharth Arora and my roll number is 102006124. I am from Electronics and Communication branch and I am a part of this project Drishti AI.
Hello everyone, my name is Girish Garg. I am of branch Electronics and Computers. My roll number is 102015034 and I am a part of this Capstone project Drishti AI.
Hello everyone, my name is Divesh Bansal. My roll number is 102006135. I am from a Capstone group Drishti AI and our group number is 56.
Hello, my name is Daksh Rathore and my roll number is 1002006 and my branch is Electronics and Communication. And for this Capstone video, I'll be representing Capstone Group Project 56. And now, moving on to the next part of the video, I'll be presenting the code demonstration of the entire project. And from there on, we'll move on to the hardware implementation and then finally the output of the code. Now I'll be demonstrating the software part of the project. The following project consists of two parts, which is one is training the model and the second is evaluating or using the model. So if I move on to the first part of the project, which is training the model, I've trained the following model on 80 hours of running data or video time. And these video data sets are open source data sets, which are mainly UBI files data sets. And the second data set is DCASS data set. And if you were to know how these data sets are annotated, for UBI file data sets, it's annotated frame-wise. And for DCASS dataset, it is annotated video-wise or second-wise. And three main labels that we are dealing with here are vandalism, fighting, and abuse. And naturally, it is important for the model to classify whether it's whenever it's not fighting and whenever it's not able to recognize abuse, it is standard or clearly just outputting normal. So we have a fourth label, which is a normal label. And for EDA purposes, I've defined a plot images function so that I can know that my data folder has the right amount of videos or the right video. And this just visualizes one of the frames for one random data set. For the data pre-processing part, I have two functions mainly, which is frames extraction. And the second part is to prepare the videos or prepare the data set, which is right here. And now what this does is that it ventures into the data folder and it picks out all the videos, prepares them frame to frame based on my sequence length, and then gives the output in the form of an NP array, which is a NumPy array. And this NumPy array is 3-channel frames of that sequence length of different videos. And why I'm trying to pre-process this data is because we want a sequence length that is adaptable for a time-distributed model. Coming to the model, I have made use of 3 major layers, which is time-distributed CNN, which is 2D. And then we have a pooling layer, and then we have LSTMs. And then at the end, we have a dense layer, which is for the output of the entire model. And then this was trained using the Adam optimizer, and then I also used the early stopping callback for 10 epochs consecutively. Why only 10 epochs? Because I have increased the batch size in total. So this is much better, and this is much more effective. And then I save the model as suspicious human activity detection LRCN model so that it can be used by our next script. And then moving on to the next script, which is the final predict script. What it does is that it defines a few hyperparameters that are required for the model to function, and it is taken from the training part of the script itself. Then it loads the model, then it sends some other buffer parameters, and these buffer parameters are essential for the model to save videos, right? For example, if we have a 10-second buffer, then it will create other parameters based on this buffer. And it depends on the user how many seconds he wants to record in the event of an event-based detection. Moving on to the output function, and this is just called whenever the model finds there's a fighting or a vandalism scene that's happening, and then it just writes the output. And this is the email alert function. It sends the email to the user if there is a fighting instance that is detected by the model. And then this is a standard OpenCV model function. What it does, it takes in the frames that are constantly being streamed and then puts it in the model. So this was a basic software overview of the entire project.
Now I'm going to explain you the hardware part of our model. We have used SolidWorks to design a 3D model, and we used PLA plus material for making this. Now moving on to our main component is Raspberry Pi 3B Plus. This model has computation speed faster than other models, and its price is much lower. This wire is used to provide the power to Raspberry Pi, and we have used a camera sensor Pi Camera V2 Plus so that Raspberry Pi and camera sensor V2 Plus combine work amazingly.